In this session, we will talk about the very important concept of Kubernetes services. First, let's establish why we need services. We know that pods are designed to be reliable, which means they can be stopped or new ones could be started at any time. So this means that clients cannot directly connect to pods because they are inherently unreliable. What we need is a stable endpoint that clients can connect to and that is always available and doesn't change. And this is exactly what the service objects provide. That is, they provide a reliable endpoint that clients can use to send traffic to the application. So this is that stable endpoint that we are talking about. And that stable endpoint actually means an IP, a DNS name, and a port that clients can use to connect to. And this doesn't change for the lifetime of the service. And then the clients are going to send requests to this endpoint. From there, the service will handle routing the traffic to the pods on which the specific application is running. And this routing is done using a label selector, which we are familiar with by now, and we are going to talk about it more in the next slide. So to summarize, a service object provides a stable endpoint. That endpoint includes an IP address, a DNS name, and a port. And there is a front end to the service, which is this endpoint. And then there's a back end, which are the pods on which the application is running, for which we have the service. And how does the service know which pods to send the request to? It is through the label selector. So here, what you are seeing is that we have these pods with this specific label. In the service configuration, we use the label selector and specified the value of the labels. And now the service knows exactly which pods to send the request to. Another way to explain this is that services have a stable front end and a dynamic back end, because as we know, pods are mortal and could come and go. This just explains what we covered, which is the use of labels and the label selector. So here, once again, we have these pods with specific labels, and then the service was configured with this label selector. And when the request will come, service will route to the request to any pod with this label, and this as well. And this is to represent the loose coupling that is implemented through the labels, and that is here, this pod also has other labels, but that doesn't matter as long as it has the label that we have specified in the selector. Traffic would be sent. And this is an example of a pod to which traffic would not be sent because the labels are not matching. Let's look at a sample manifest. This is the deployment, which we have seen before in our deployment discussion and hands-on. And this is how we can create a service on top of the deployment or on top of the pods that are managed by this deployment. The important thing to note here is that these pods are created with this label. And then in the service, in the selector section, we are specifying the label to use to select the pods to which traffic should be sent. So this is how we are connecting the service with the pods that would be running our application. Also, another important settings to check is the ports. We will discuss the different kind of services, but here just at a higher level, this is telling what port the service is going to run at, or the endpoint which the service is going to expose, what port would that be? And this is the port on the container. So if we go back to our service, the first port is this one. This is the port for the service endpoint. A little bit more granular details in how the service sends traffic to the pods is it uses another object called endpoint slices. Endpoint slices maintains a list of healthy pods associated with the service. And then when deciding which pods to send to, the service uses the endpoint slice pods, the list of pods in the endpoint slices, to pick the pods to send traffic to. Because although the pod could have the exact label, but it could be unhealthy, or it could be coming up and not in a state where it can serve traffic. So we should not be sending traffic to that pod. That's why we use endpoint slices for that. Let's talk about the various service types now. Very important concept. There are three types of services. One is ClusterIP, the other is NodePort, and the third one is load balancer. First, let's talk about the ClusterIP service. This is the most basic form of service. It provides a reliable endpoint within the internal pod network. So here you're seeing the ClusterIP service, and it is providing an endpoint, but only within the internal pod network. This is how I am representing the internal pod network with this black line. And that is being emphasized here from the connection which the user is making by showing the fact that the user or the client is within the context of a node. And obviously the node is within the internal pod network. So that is why this cluster IP service is accessible to the user, because the request is being sent from within the context of a node. So this service is good. It's providing a reliable endpoint, but how do external clients access the service? For that, we have another service called the NodePort service. The NodePort service type exposes the service to external clients. It does that by exposing an IP, an external IP, and a port, which we call NodePort, to the external network. Now, one thing to note is that since I work within the cloud space a lot, and chances are that you also work on the cloud, I have used a distinction between an external network and a public network, because as you know, you could be on a private subnet, and that is a network external to the Kubernetes internal pod network, but it's still not a public network. And then you could be on a public network, which is accessible from the internet. That is what I'm calling a public network. But for now, let's just abstract these two out, and then let's just call these outside network. So how NodePort service works is it is going to expose an external IP and a port on each of the nodes running in the cluster. So this way, if the request comes into that endpoint to any of the nodes, it will route that request to the ClusterIP service. And then from there on, the ClusterIP service knows, as we saw from the previous slide, how to route the request to. So that's why that is what is being represented here. Like, for example, the request came in from one user, which is in the external network, which could be a private VPC subnet, but not necessarily a public network. And then it could have come to this node, or this node, the flow would have been the same. That is, the request would have gone to the cluster IP endpoint, and from there on, it could have gone to any of the pods. And same flow for the user coming from the public network. It's going to follow the same path. Another thing to note is that the range of the port which NodePort service exposes is on the high range, which is the one listed here. Also, one interesting thing to note here is that NodePort service is built on top of ClusterIP. So it basically leverages ClusterIP service implementation and just exposes external endpoint on each of the nodes so that external clients can communicate with the service as well. Let's look at a sample manifest for a NodePort service. So one new thing that you are seeing from compared to the ClusterIP service that we saw earlier is this, the NodePort to use. Now, the NodePort service has certain limitations. First thing is that it opens up port from the high range. The other limitation is that clients need to know the IP or DNS addresses of the nodes of the Kubernetes cluster. And the third one is that the nodes need to be on the public network, which is accessible from the internet if you are exposing it to internet users. You can address these limitations using the load balancer service, and it is Like the NodePort service, it is also built on the ClusterIP service and the NodePort service built on top of that. And it integrates with an external cloud load balancer, which it leverages to provide external public access to your applications. So here you are seeing a load balancer service, and we can clearly see that it is the same setup as the NodePort service, but we just have an external load balancer, which is the cloud load balancer. And that is why I'm using AWS load balancers icon here, but it could be Azure, GCP, Linode, or any other cloud provider. And the user is sending requests via the external load balancer. And then the load balancer is routing request, because the load balancer is not in the internal pod network. It is on the external network. Now, this is where when our discussion about the distinction between the external network and the public network is paying off now. So the load balancer is on an external network. So it is going to use the NodePort to connect to the service. And then the NodePort service is going to route to the internal ClusterIP service. And that is how the request, we already know that the request would be routed to the pods that are running our application. So this is how the whole thing works in a load balancer service setup. And this is how we can expose our Kubernetes services to the internet or external networks. One important thing here is that the load balancer in the load balancer service, it operates at the transport layer, which is layer 4, the TCP and UDP layer. It doesn't understand HTTP. For that, we have ingresses, which we're going to discuss next. But before we talk about that concept, it's time to do the hands-on for services. We have covered enough topic for services. And now we want to see all these topics in action and do a hands-on. So I look forward to seeing you in the hands-on video.